Welcome to the DIY Honda Garage channel. The DTC P2185 indicates a high voltage condition in the Engine Coolant Temperature ECT Sensor 2 circuit. This specific diagnostic trouble code is crucial as it relates to the vehicle's powertrain control module, PCM, and its ability to monitor engine temperatures. If the ECT sensor reports inaccurate temperature data due to high voltage, the engine's performance may be compromised, leading to inefficiencies and potential damage. It is essential to conduct a thorough diagnosis to pinpoint the root cause of this issue before performing repairs. The ECT sensor itself is located near the engine block, providing real-time temperature readings to the PCM, which ensures optimal engine function. Proper troubleshooting steps must be taken, as misdiagnosis could lead to unnecessary part replacements or further complications. DTC P2185 refers to the ECT Sensor 2, which plays a vital role in measuring the engine coolant temperature. This sensor sends critical data to the PCM, which uses this information to make necessary adjustments in fuel injection and ignition timing. If the reported voltage from the ECT Sensor 2 exceeds 4.92 volts, it indicates a circuit high voltage issue. This can lead to incorrect engine temperature readings and can cause various performance problems. The ECT sensor is positioned near the engine block to accurately capture temperature fluctuations of the coolant. Since the PCM relies on accurate readings to optimize engine performance and emissions, any malfunction in the ECT circuit must be addressed promptly. Understanding the possible causes of DTC P2185 is crucial for effective troubleshooting. One common cause is a short circuit in the wiring, which can result in unexpected voltage levels being sent to the PCM. A faulty ECT sensor itself can also induce high voltage conditions, ultimately risking miscommunication between the sensor and the PCM. Additionally, loose or corroded connectors in the circuit can lead to intermittent readings, which also affect the voltage level. These issues can contribute to the PCM believing the coolant temperature is incorrect, leading to suboptimal engine operations. Recognizing these causes helps the technician focus their diagnostic efforts on the most likely sources of failure. The symptoms associated with DTC P2185 can manifest in various ways. A common indication is a trigger of the check engine light, warning drivers that there's a potential issue with the vehicle's engine management system. Moreover, when the engine temperature readings are faulty, it may lead to noticeable engine performance issues, such as sluggish acceleration or rough idling. Furthermore, if the PCM misinterprets the coolant temperature, it can lead to increased fuel consumption as the engine compensates for perceived low temperatures. These symptoms may also hinder overall drivability, making it vital for owners to address the DTC promptly to maintain vehicle performance and efficiency. In the first troubleshooting step for DTC P2185, start by turning the vehicle to the on mode without starting the engine. This action powers up the vehicle's electrical system and facilitates checking various parameters using the Honda Diagnostic System, HDS. Focus particularly on the ECT Sensor 2 readings. You will need to monitor the specific voltage value of the ECT Sensor 2, which should be above 4.92 volts. If the current conditions match this threshold, it indicates a confirmed failure, and you should proceed to the next step. If the conditions do not match the threshold, it may indicate an intermittent failure, prompting an inspection of connectors or the potential for looseness in the terminals connecting the ECT sensor to the PCM. For the second troubleshooting step, ensure that the vehicle is turned to the off mode to safely work on the electrical components. Disconnect the ECT Sensor 2 specifically removing the 2P connector, which presents access to the sensor terminals. Next, use a jumper wire to connect the terminals A and B in the ECT Sensor 2 connector. After doing this, turn the vehicle back to the on mode, again without starting the engine. Now, check the ECT Sensor 2 reading with the HDS. The voltage should still exceed 4.92 volts. If this value is attained, it implies that the wiring up to the sensor is intact, prompting you to move on to the next diagnostic phase. However, if it does not meet the threshold, replacement of the ECT Sensor 2 might be necessary. During the third troubleshooting step, begin by turning the vehicle to the off mode and removing the jumper wire from the ECT Sensor 2 connector. Safety is paramount in this process, so ensure that proper procedures are followed. With the vehicle in the off mode, prepare to turn the vehicle on again to measure the voltage at the ECT sensor connector. Specifically, measure the voltage between test points 1 and 2, one at the sensor terminal and the other at body ground. The expectation is to find a voltage of approximately 5.0 volts. If such a reading is obtained, you can confidently proceed to the next step. Should you not achieve this voltage, it indicates potential issues related to the TW2 sensor line, which will require further investigation. In the fourth troubleshooting step, commence by ensuring the vehicle is in the off mode. Utilize the HDS to jump the SCS line and allow it to sit for over 1 minute. This action secures the short circuit SCS and prepares the system for testing. Next, disconnect the PCM connector A, 51P. With both the ECT Sensor 2 connector and PCM disconnected, check for continuity between test points 1 and 2. You will want to measure continuity from the ECT Sensor 2 2P connector's terminal 1 to PCM connector A, pin 28. A successful continuity check indicates that the SG6 line is functioning correctly. If continuity is absent, it signifies an open circuit in the SG6 wiring, necessitating repair of the wiring between the PCM and the ECT Sensor 2. For the last troubleshooting step, again, ensure that the vehicle is in the off mode for safe diagnostics. Jump the SCS line using the HDS and wait for more than 1 minute to allow it to take proper readings. After this period, disconnect the PCM connector A, 51P, once more. This time, you will check for continuity between test points 1 and 2, focusing on the TW2 sensor line. Specifically, you will check continuity from ECT sensor terminal 2 to PCM connector A, pin 43. If continuity exists, this indicates that the TW2 sensor line is operational. However, if no continuity is found, it necessitates an open circuit repair between the PCM and the ECT Sensor 2. Upon completing the necessary repairs for DTC P2185, it's vital to conduct a final verification. This step involves confirming that all repairs were effectively implemented and have resolved the underlying issue. Recheck the parameters of the ECT sensor using the HDS to ensure that voltage levels are now within the specified limits. Additionally, a test drive should be conducted to monitor the vehicle's performance in various conditions. During the test drive, pay attention to any warning lights and the overall engine functionality. If the check engine light does not illuminate and the performance is stable, you can conclude that the repair has been successful. These steps ensure that the vehicle is returned to optimal functionality. Preventive maintenance plays a critical role in avoiding issues like DTC P2185 in the future. Regular inspections of electrical connectors and harnesses are essential for identifying signs of wear, corrosion, or damage that could lead to intermittent or persistent errors in voltage readings. It is advisable to make these inspections a routine part of your vehicle maintenance regimen. Additionally, checking the integrity of wiring can prevent short circuits or open circuits that compromise sensor functions. Timely replacement of faulty sensors, like the ECT sensor, is crucial in maintaining the vehicle's performance. This proactive approach ensures that issues are dealt with before they escalate, promoting longevity and reliability for the Honda CRV. In conclusion, DTC P2185 signifies a critical issue related to the Engine Coolant Temperature Sensor 2. Identifying and understanding the specifics of this diagnosis is crucial for accurate troubleshooting. Each diagnostic step allows technicians to rule out potential causes systematically, ensuring that repairs focus on the actual source of the issue. Proper repairs and final verification not only restore the vehicle's operational capabilities, but also enhance reliability and performance. Implementing preventive maintenance measures can significantly reduce the likelihood of recurrence of such faults. As a result, owners can ensure their Honda CRV operates efficiently and remains in good condition for the long term. Please like and subscribe to the channel. See you next time.